as we speak now, my foot is buried into the firewall and we're doing 74 kilometers an hour. It's not going any faster. Wow. We're accelerating with no dramas at all. G'day, I'm Paul. This is the BYD Shark. It is a plug-in hybrid dual cab ute, and today we're going to be towing at its absolute limits. That is 2,500 kilo with a brake trailer and maximum payload as well. In addition to that, we're also going to be using a trailer dyne, which is a device they use during vehicle development to see how much stress a vehicle can handle before it just gives up. So it is going to be an interesting day. We have also filmed a full review of this vehicle, plus a drag race against my Raptor to see how quick it is. Links to those videos are in the comments section below. Now, if you do want to skip ahead to other parts of this video, you can use the time codes that are on the screen, or if you're on YouTube, you can scroll down and use the chapters below, and make sure you subscribe as well so you don't miss anything. So to kick things off, we're going to tow at the vehicle's limits. That is 2,500 kilos with a braked trailer. We've also got payload in the rear along with me as well. So we are at the vehicle's limits for towing. I'm going to run you through the numbers as well, just so you've got them at the top of your head. GVM 3,500 kilos, GCM 5,750 kilos, 2,500 kilos with a brake trailer, payload 790 kilos, front axle load limit 1,607 kilos, and rear axle load limit 1,893 kilos. So those are all pretty important numbers, because if you are going to be towing, you need to make sure you don't exceed things like your payload. You also need to make sure you don't exceed things like your GVM, because you can get in trouble if you are driving on the road and your GVM or your combination mass exceeds what the vehicle is permitted to be at. So please take that stuff into account. We are literally at the vehicle's limits, so this is going to be worst case scenario, but we do want to see how it performs, because to be honest, I've got my doubts. So let's give it a shot. This is our hill road. We've used this before on our big ute mega test and also our SUV mega test. It basically simulates a country road. We've got a very steep incline and then also a long gradual decline as well, so it gives us a good idea of what this is like in real world conditions. It is hot outside at the moment as well, 31 degrees, so this is really going to be putting this car through everything it can. So let's get started. Okay, here we go. So when I hooked up the trailer, it basically did a light test for me, which is pretty cool. And then it disabled all the safety systems. So this is interesting. This is a pre-production car, so there's a chance that some of this stuff isn't working as it sort of intended, but it switched off stuff like AEB, which I find interesting when towing a trailer. So we'll see what happens there. Okay, so I'm basically going to give you impressions on what this feels like in terms of the ride and also the acceleration, which is probably the thing I'm most interested in. I've got it in hybrid electric mode. So you've got full EV mode, where it just runs on battery until the battery drains. And just as a reminder, it has a 30 kilowatt hour battery that gives you around 100 kilometers worth of driving range. And then I'll also give you impressions on what it's like when we try and accelerate up our really steep hill, just to get a vibe for that too. But I'm running it in hybrid electric mode at the moment, which means it's either running the vehicle entirely on battery, or when it needs a little bit of extra power, it will kick on the internal combustion engine to support charging the battery, which then runs the electric motors. You've got two of those, one on the front axle, one on the rear axle. This makes around 300 kilowatts of power, so it is a lot of mumbo, but it does weigh a lot. 2,700 kilos is your curb weight, and curb weight is basically the weight of the vehicle with a full tank of fuel but no passengers. So every passenger you add is eating away at your payload capacity. Okay, so we've got our long decline here. I'm going to ride the brakes here. What this also does is actually uses regen. So right now we're generating 60 kilowatts of energy that is plumbing back into those batteries to charge them. So that's one of the big bonuses here of driving a plug-in hybrid vehicle, that you're actually generating electricity each time you're slowing down, which is great news, which means you're able to recharge that battery each time the vehicle slows, and it gives you that energy to use again as you go up the hill. So here we go, we've got our climb out of here. I'm going to give this just a little punch. Honestly, I am lost for words. If we were in a four-cylinder vehicle like a Hilux or something, you have to have your foot planted into the firewall to get it to move. This really is pulling along very nicely with just no stress at all. You would never know a load was on the back. All right, here is our big climb. So this is a 15% grade. It is a really steep hill. It'll challenge the vehicle now. I'm just going to go full throttle here just to see how willing it is to accelerate. Wow. We're accelerating with no dramas at all. There's 70, 80 k's an hour. Wow. Really impressed with this. So look, first impressions, this is doing significantly better than I thought it would. Even on the ride front, this is a pretty sort of choppy country road. It is riding really nicely with such a big weight over the rear. We've got the downball weight set at 250 kilos, and that is about where you'd want it to be. It's about 10% of the total trailer weight, so about sort of where you want it to be, and it is humming along really nicely, especially given we've got weight in the rear as well. So yeah, very, very good. So this last bit of our circuit is a long descent. So we'll see what it's like here in terms of engine braking. Well, it doesn't really have an engine to brake with, it just uses regen. So we'll see how this goes. Yeah, it's quite a unique setup because depending on the speed that you're doing, sometimes the engine is actually directly driving the front axle. Other times it's charging the battery, and then other times again, you've got the engine off entirely. But right now in this driving mode here while we're towing, it's actually doing a really nice job of just moving everything along. And I love the fact with the regen, you can switch it between standard and high regen. So when it is in that high regen, we're generating that 60 kilowatts of energy, and that is sort of pushing all that energy back into the battery. There are limits to systems like this in terms of the heat they generate when they're creating electricity. So it does go between 50 and 40 and 60 when it sort of gets a bit hot. But for the most part, what we've just done there is a pretty standard country road, and it's tackled that with absolute ease. Now this bottom section will be interesting. This is basically a choppy section, gives us an idea of what the ride's like once we get a couple of bounces in there. This is about 1 ton down on something like a Hilux or a D-Max, but that is something they're looking to address by offering a 3.5 ton braked version. But here's the bumpy sections. Feels surprisingly compliant, yeah. I don't know whether it's just this has a lot of mass down low that keeps it really nice and in check, but with 2.5 tons on the back, especially when accelerating, you really don't notice that it's there. Okay, so we're on the start line now with our trailer dyne. Pretty cool piece of machinery. It is basically a device that's able to adjust the load that it places on the vehicle depending on the numbers I put into this computer here that communicates with it. It's effectively a retarder, and they use it in vehicle development to put artificial strain on an engine, so the engine has to work hard, and they'll run cars around the bowl here for like days on end. What we're going to be doing with it today is matching what we did with our recent ute test, where we set the load to 3 kilonewtons. Now, what does all that mean? I'm going to throw quickly to a section in that ute test that explains how our trailer dyne works. What exactly is a trailer dyno? Well, that is a very good question. It may look just like a normal box trailer here, but it is actually a pretty complex piece of machinery with a lot of electrical components as well that allow us to do some more dynamic testing with the ute. So let me show you what it looks like on the inside. Think of this trailer as an anchor. We hook this up to the car. It weighs 1,600 kilos before we even touch any of the controls. What we're then able to do with the controls is vary the weight of the anchor that's behind the vehicle, and that allows us to simulate different loads. In this particular setup here, you can see there's a retarder, there's also a differential, and we're able to then communicate with this using a computer inside the car and vary the load from no load, which is just towing a 1,600 kilo trailer, all the way through to 10 kilonewtons of load. And to put something like that into context, it would be like having a fully loaded dual cab ute going up the steepest hill you can find, and it's constantly pulling it back. So for us, we're going to dial back the load to 3 kilonewtons in an automatic load setting, and that's going to simulate a steep incline that some of these utes are going to fail to overcome. The automatic load setting allows the dyne to temporarily limit load when the vehicle changes gears to gradually apply it again. So it's going to simulate what you will experience driving up a big hill. So it is set to 3 kilonewtons. We're going to do a run from 0 to 100. Then we're going to do a lap of the bowl here to see what the fuel economy is like with that 3 kilonewton load. We'll compare the 0 to 100 and the fuel economy to some runs that we did earlier to see how much extra fuel it's going to be using when it is towing. And then it'll also give us an idea of how much extra fuel you're going to be using compared to other utes that we've tested previously. I want to see what it's like when that battery expires and runs out. What is the vehicle going to do and how does it cope? And I'm also going to pop this, actually I can't do that. So it says here, I can't switch it into sport mode when it's in trailering mode. So we'll just leave that as it is. And here we go. All right, I can feel the weight on the back, but it's accelerating nicely. You know, there's 70, 80, 90, I think it's gonna make 100. Boom, 100, very nice. Yeah, that was very carefree. All right, let's set cruise control to 100 k's an hour. We'll do a lap for fuel economy. Unfortunately, it didn't all quite go to plan. Typically what we do with this test is we do our 0 to 100 run, and then I'll do 2 laps of the bowl with cruise control set at 100 so that we can get our fuel economy. And the whole purpose of that is we can compare the fuel economy when the vehicle is laden with the trailer dyne to fuel economy when it's unladen, and then we can get a percentage difference. It just gives us a good idea of how much your vehicle is going to use when you are towing. Now the problem is when we started doing our lap, I did notice that there were times when the vehicle with cruise control set at 100 would start slowing down to sort of around 70, 80 kilometers an hour, and then it would speed back up again. And that was when battery was around 20 or 25%. Then when battery got to about 15%, it actually started slowing down to 70 odd k's an hour, and this is what happened. As we speak now, my foot is buried into the firewall and we're doing 74 kilometers an hour. It's not going any faster. We're basically running the internal combustion engine as hard as we can. Battery is virtually empty there, as you can see. So this is what's going to happen if you get to the point where you are effectively going up a long incline with a trailer. So as you can see there, I wasn't able to accelerate past that 70 odd kilometre an hour mark. The engine was screaming. And if you look at the bottom corner there, you can actually see the power production. That internal combustion engine, the 1.5 litre 4-cylinder, is rated to around 130 kilowatts of power. It wasn't producing that peak power. So it could be a number of things. It could be exhaustion being too hot, or it could just be that it's producing a majority of the power that it needs to drive the front axle, because it does that as a direct drive setup at around 70 kilometres an hour. And it might be using the balance of the power to try and charge the battery, because a plug-in hybrid is typically set up in a way where it wants to have a minimum amount of energy in the battery so that it can actually give you that burst of acceleration as required. So it may have been trying to still charge it while also moving the vehicle. And look, this is really an edge case. And I say an edge case because there are going to be very few cases where you're going to be at wide open throttle using all of the combined system's power for long durations of time. You might be doing it when you're overtaking or something like that, but what this illustrates is an example where you're towing at the vehicle's capacity, you're going up a long, steep incline, perhaps you've just done an overtake, your battery was already low because you've driven more than 100 kilometres and drained that capacity. So there could be an opportunity where this does actually happen, and it is just something worth keeping in mind, because while it may not ever happen to you, it is something that could potentially happen, and this is the end result of that. You won't be able to accelerate past 70 k's an hour. The vehicle did eventually fix itself when we pulled over. The engine ran at high RPM until it got to the point where it charged the battery enough. You also have to keep in mind that there are energy draw limits on systems like this. So while it is rated at peak power output of 321 kilowatts, those two electric motors actually have a much lower rated output. Peak power output is only for brief periods of time. So you are going to get to the point where you're exhausting the electric motors or the battery system in terms of current draw, and you could end up in a situation like this. So just something worth keeping in mind. Now I'm going to run over the figures in just a second, but just in case you're wondering, how does this compare to any other vehicle that is internal combustion? Well, we actually just had the new Prado Kakadu that weighs around the same as the Shark. There's about 100 kilos weight difference. We actually set the trailer dyne to 3 kilonewtons on that and did 5 laps of the bowl. I just wanted to illustrate what would happen if you just kept going. And basically 5 laps of the bowl there, you can see the fast forwarded footage now. The speed did not flinch. It basically locked in its speed. It did its 5 laps without even thinking about it. And that just goes to show you that an internal combustion vehicle will just continue doing those high load scenarios without too many dramas. The engine might get a little hot, you might get the fan kick on, but it is designed to do that over long periods of time, which is why it is going to be easier to tow with a vehicle like this under those high load scenarios. So just something worth keeping in mind. They're not direct competitors or anything, but I just wanted to show you what would happen. Now let's have a look at the figures. So the figures are actually pretty impressive. When it did have that energy in the battery and it wasn't in that sort of edge case scenario, 0 to 100 unladen was 5.7 seconds. And what I'm going to do now is overlay all of this on the screen so you can actually digest this and compare it to other dual cab utes that aren't plug-in hybrid but are just sort of typical dual cab utes. The reason the 0 to 100 time was impressive laden, which was closer to that sort of 12-second mark, is because most dual cab utes that we test can't actually break through 100 k's an hour. They really just don't have the energy to bust through that, whereas this, when it has charge capacity, it's able to use internal combustion and also that battery to really propel it forward. So those figures were quite impressive. In terms of your fuel economy, So with the vehicle unladen, 6.2 litres per 100 k's when the battery was drained, so really good sort of figure there. When it was towing though, 30 litres per 100 k, so an increase of 383%. Now comparatively, it is going to use more fuel than an equivalent 4-cylinder dual cab ute, because it is having to work harder once the battery is drained to tow such a big load. Where this is really going to make a difference though is if you're doing hilly stuff where the vehicle's able to regen energy as it's sort of going down hills, or perhaps if you've been able to charge the vehicle before you drive, you're able to then take advantage of that buffer within the battery. But as a percentage increase, that is a massive jump and higher than most other dual cab utes that we've tested. Look, the final point I'm going to make as well is with regards to the regen. You would have seen there when we were doing the hill road that basically the regen dips in and out as the system gets hot. What you're going to find is that with a typical vehicle that has gear reductions or just a standard sort of gearbox, and you're able to use engine braking, you can sustain that engine braking for longer periods of time. Whereas what you're going to find here is if you run out of regen and it's in a state where you've sort of heated it a little bit too much, you're going to be relying on the friction brakes alone. I do have concerns over very long descents that this could become problematic if the regen isn't functioning as it should. So just something to keep in mind. There's no ability to engine brake here. It is just going to be down to regen and the friction brakes as well. So there it is. Mixed results here. Really impressed with the Shark once it is charged. It's able to explosively accelerate, really rides beautifully. It does a great job when it comes to towing a load like this across our hill roads. So that was all great. But you can see when you get to those edge cases where you're really pushing the vehicle at load that it can become problematic once the battery runs out. So just something worth keeping in mind. And sorry about the shirt. I was doing some TV stuff this morning and had to look official. So that's why I'm wearing this randomly. If you did enjoy this video, please make sure you like it, you share it with your mates. And if you haven't done so already, subscribe to our channel. Let us know what else you want us to do a tow test on. But until next time, take it easy.